Hello and welcome to Venslov Academy. In this video we'll be looking at underfitting versus overfitting, because this is a really important topic within machine learning when you are to choose a model based on the data that you have available. So what is underfitting? Well, underfitting is when you have a high bias within your data. So you are basically oversimplifying the problem, which is not doing very well within your training set. So for example, on this graph right here, we are oversimplifying the problem by just taking a linear approach and just take a line straight through our data and say, okay, that fits kinda okay. But as we see here, we are not really categorizing these into the colors because we have a lot of red dots on the top, which seems okay, but we also have the same amount or on the bottom in the blue area. So by oversimplifying this problem, by just categorizing them like this with a linear approach, we are really underfitting right here. And an example of looking at the underfitting problem in a bit more simplistic way is by looking at this categorization problem here. So here we have some objects that we want to categorize. So on the right we have a category called Lego, and on the left we have no Lego. But the problem here is that, well, this seems fine for the right side because all this is Lego, but on the left we also have this Lego minifigure, which is actually also Lego, even though that it is not a Lego brick. So the house and the car is correctly categorized, but we are failing on this particular object here. So a better approach based on this data is to make the categorization of Lego bricks versus not Lego bricks, because then we are not oversimplifying it by taking this large term, the Lego, when we are not seeing anything else than Lego bricks. Why not use the category Lego bricks here? Because then we can just say that everything that is not Lego bricks, which is actually all that we have here, could stay in this category. And right now we are having a much better fit based on this problem. So if we are to look at overfitting, which is compared to high bias, is high variance, it will look like this. So compared to underfitting, we have overfitting, which is, instead of high bias, we have high variance. And here we really try to overcomplicate the problem more than necessary in order for us to perform very well on our training set. And for example, we see right here, instead of having this linear approach, which we had in the underfitting example, we here try to match the data exactly. So we just basically follow the blue points around here, and also in this corner case up here. So one could imagine that, for example, if we now trained our model based on this, we get very good result based on the training set. But when we see new data from the real world, we could probably also have a blue dot right here, or we can have run one right here, because it is very near to the other blue spots. But because our model have kind of learned the way of the training set, it will get an error on this, because we are actually saying that this is out of the area where it is supposed to be in order to be blue. Oh, I see now that this is gone around, so this should be cornered off right here, of course. So just a bit of a drawing error, but you get the example. So if we take this back into our little categorization problem, we see here that now, instead of, for example, saying Lego bricks, we want to complicate this. So now we say Lego bricks with only 4 studs, and on the other side we have not Lego bricks with 4 studs, and that is still valid because we only have these Lego bricks right here with which all have 4 studs, so the 4 here on the top, and on the other side we have no Lego bricks with 4 studs. But if we then trained our model based on this and moved it out to the real world, or got some new data in, we could imagine that we, for example, got this data point right here. So that will probably get within this right side of the graph, but because that we have complicated our problem, which before were only Lego bricks, this is now an actual error, because this is not a Lego brick with 4 studs. This actually have 8 studs. So this should belong to this side, even though that is still a Lego brick. So here we have overcomplicated the problem. So what you want in machine learning is basically to get in between. So Instead of underfitting, as we see here in the top, where we just have no Lego versus Lego with the linear approach here, you want to be in between this underfitting and the overfitting, which were complicating the problem even more with adding the force studs and trying to match the training data as closely as possible, but you want your model to be in between based on your data. So here we have taken a more loose approach, but not loose enough to having it underfit and not tight enough to have it overcomplicate itself by overfitting. So here we are taking this line, for example, right here. So even though that we see that we have a red dot in here and a blue right here, we could imagine that if we got new pieces in, for example, this Lego brick right here, this could, for example, be within this place here, but this model here has a lot of errors and are missing a lot, and here we will again miss it because if it is placed right here, it will be out of this model that we have trained here. So in machine learning, you really want to be in between overfitting and underfitting.